Hi, in the in this video we will see about the uninformed search strategy. In that we will be seeing depth first search algorithm. As we see, as the name indicates, we can identify that DFS is one of the fundamental search algorithm used to explore possible solutions in problem space, especially in domains where the solution requires traversing through deep states. DFS explore a problem solution space by dividing deep into the branch of search tree because backtracking and exploring other branches. It is commonly used in tasks such as pathfinding, game tree, exploring, and puzzle solving. Okay, what is DFS? It is an uninformed search strategy in AI. It explores the problem space by following a single path deeply. DFS expands successor states of the current state. It backtracks and explores alternate branches when it reaches the dead end. DFS is a blind search strategy that is systematically explore as far as possible along the branch before backtracking. DFS utilize LIFO, last in first out stack, to manage the order of state exploration. First one is initialize a stack with the starting state. While the stack is not empty, pop a state from the stack on the top. If the state is the goal state, return success, expand the state, and for each successor rate, if the successor is not yet visited, push it into the stack. Search fails, return failure, no goals found. And DFS has several important properties that impacts its performance and application. First one is time complexity, order of B and D, where B is the branching factor, number of children nodes per parent, and D is the depth of shallowest goal. Second one is space complexity, order of B into D, as the algorithm needs to store each node along with the path from the root to current node. DFS characteristics are DFS requires less memory compared to algorithm like BFS because it only stores a single path from the root to current node, and it can get stuck in infinite loop. In cyclic graph, DFS can get stuck in infinite loops unless cycle checking is implemented. Advantages of DFS. DFS has several advantages, making it suitable for certain types of possible problems. Space efficiency is one of the problems, since DFS only needs to store the node on the current path. It's much more efficient compared to the other algorithm like BFS. Deep solution. DFS is particularly effective when solutions are deep into the search space or when the goal is likely to found by exploring a long chain decision. And simplicity. DFS is easy to implement using recursion or an explicit backstack. For example, DFS is particularly useful for puzzle or games with deep solution space, such as 8 puzzle or solving maze. Coming to disadvantages, we can say that it does not guarantee the shortest path or the most efficient solution. It may explore longer path before finding the goal. Getting stuck in infinite loop is one of the disadvantage. In cyclic graph, DFS can loop indefinitely unless cycle detection is added. Exponential time complexity. In worst case, the time complexity of DFS is exponential, which makes it impractical for large search space. If you use DFS to search for a goal in maze with loop, DFS may explore the same loop repeatedly without ever finding to exit. And when we come to application, it is used in pathfinding in maze, game tree search, and topological sort, and for solving puzzle. DFS is used in solving maze whether the solution is likely to be found by taking a deep exploration of path. these are the things that we have to know about DFS. Thank you.